All right, 13, 14, and 15. The last ones on here are ones where if you do the test, as x approaches 3, I would get a number over 0. And division by 0 is undefined. If it's not 0 over 0 and you have a number over 0, you're either going to get plus or minus infinity when you plug those in. So in this case, it's the same kind of thing that we did on those previous ones. I'm going to put numbers in where I approach that value, and I want to see, do I have a positive answer or a negative answer? So I know if I have a positive infinity or a negative infinity for my limit. So we are saying x approaches 3 from the left-hand side. Now you don't want to go down too far from that, and so if I take a little bit off of 3, I am going to use 2.9. Don't want to round it down too far, but you don't want to have too many decimals to have to deal with. I suppose on Alex I'll probably use 2.99999 or some crazy thing, but 2.9 should probably work. So what I'm going to do is I'm going to do 1 over 2.9 minus 3 squared. Again, I'm really not concerned about the answer, I'm concerned about the sign of my answer. So I'm going to have 1 over, if I take 2.9 minus 3, I get negative 0.1, but when I square that, I get a positive 0.01. So I get a positive over a positive, which means I'm going to get a positive, and so infinity is going to be the limit on this one as x approaches 3 from the left-hand side. Here, as x approaches 3 from the right-hand side, I just want a little bit bigger than 3. So 3.1 is what I'm going to plug in. So I'm going to have 1 over 3.1 minus 3 squared. So 3.1 minus 3 again would be 0.1. When I square my 0.1, I'm going to have 0.01. So again, I'm going to have a positive over a positive. And so as this one approaches 3, it's going to approach positive infinity. In other words, just infinity. So since the limit as I approach from the left-hand side is the same as the limit as I approach from the right-hand side, the limit of my function is going to be the same thing. The limit as I approach from the left was infinity. The limit as I approach from the right was infinity. So the limit of the whole function is also infinity. So this happens when you try to evaluate directly and you have a number over 0. Part B, if I move that down so I can see part B. Again, if I would put 2 in here, I would get 3 over 0. So I know my limit's either going to be positive infinity or negative infinity. So as I approach 2 from the left-hand side, I'm going to use 1.9. So I'm going to have 3 over 2 minus, not negative 1.9, 1.9. So I'm going to get 3 over 2 minus 1.9 would be 0.1, 0.1. So again, I'm not concerned about the numerical answer. I'm concerned about the sign of my answer. I'm going to have a positive over a positive, which means I have a positive. I'm going to approach positive infinity as I come from the left-hand side. Right-hand side, I'm just a little bigger than 2, so I'm going to use 2.1. So I'm going to have 3 over 2 minus 2.1. So I'm going to have 3 over a negative 0.1. I have a positive on top and a negative on the bottom. A positive over a negative is a negative, which means as I approach from the right-hand side, I'm going to be going to negative infinity. Well, since my limit as I approach from the left is positive infinity, but my limit as I approach from the right is negative infinity, the limit as I approach 2 does not exist because they don't approach the same value. So number 14, as I look at this one, I'm doing the limit as x approaches 3. Again, if I would put a 3 in there, 3 minus 1 is 2, but 3 minus 3 is 0, I would get 2 over 0. Since I have a number over 0, I know I'm either going to get infinity or negative infinity. So, as x approaches 3 from the left-hand side, I'm going to use 2.9. So 2.9 minus 1 over 2.9 minus 3. 2.9 minus 1 is 1.9. 2.9 minus 3 is negative 0.1. I have a positive over a negative, which is going to be negative, and so the limit is going to be at negative infinity. As x approaches 3 from the right-hand side, just a little bigger than 3, I'm going to use 3.1. So 3.1 minus 1 over 3.1 minus 3. So this is going to give me 2.1. This is going to give me a positive 0.1. So I'm going to have a positive over a positive, which is a positive. So my limit here is going to be infinity. So as I approach from the left-hand side, my limit was negative infinity. As I approach from the right-hand side, it's positive infinity, since those two things are not the same. As I approach 3, the limit does not exist. Part B on number 14. I am doing the limit of my expression, again, as x approaches 3. So if I would put 3 in here, 3 squared is 9, 9 times 4 is 36. But on the bottom, 3 minus 3 is 0, 0 squared is 0, so again I get a number over 0. Anytime I get a number over 0 when I evaluate directly, I know my limit is either positive infinity or negative infinity. So as I approach 3 from the negative direction, a little smaller than 3 would be 2.9. So I'm going to do 4 times 2.9 squared over 2.9 minus 3 squared. 4 times 2.9 squared is 33.64. 2.9 minus 3 is negative 0.1, but when I square that, I get positive 0.01. So I get a positive over a positive, which means I have a positive. So positive infinity is going to be my limit as I approach from the left-hand side of 3. As x approaches 3 from the positive direction, or from the right-hand side, just a little bigger than 3 would be 3.1. So 4 times 3.1 squared over 3.1 minus 3. Let's erase that whole thing. 3.1 minus 3 squared. So 4 times 3.1 squared. Again, really the number's not important, so if you know by looking at that, that's going to stay positive, more power to you. I'm just going to put the number there, but it's a positive number. Same thing on the bottom. 3.1 minus 3 would be 0.1, and when you square that, it's going to stay positive. It happens to be 0.01, not that that's important. I'm going to have a positive over a positive, which means I have positive infinity for my limit. So, as I approach from the left-hand side, my limit was positive infinity. As I approach from the right-hand side, my limit is positive infinity. That means my limit does exist. If I could write, it would be positive infinity. One more, actually 2 more, but one question with 2 parts. So on my next one, if I'm doing the limit as x approaches 3, I would have 5 over 3 squared is 9, 9 minus 9 is 0. So again, I get 5 over 0. I know that my limit's going to be either positive infinity or negative infinity because I have a number over 0 and not 0 over 0. So, as I approach 3 from the left-hand side, again, I'm going to use 2.9. So 5 over 2.9 squared minus 9. Well, the top's going to stay 5. 2.9 squared minus 9 gives me negative 0.59. I have a positive over a negative, so negative infinity is what that's going to approach. As I approach 3 from the positive direction, so just a little bigger than 3, I'm going to use 3.1. So 5 over 3.1 squared minus 9. 5 on top. 3.1 squared minus 9 gives me 0.61. So I have a positive over a positive, which means positive infinity. So in this one, as I approach from the left, I got negative infinity. As I approach from the right, I get positive infinity. Since those are different, the limit does not exist. And one last one here. This one we are doing the limit as x approaches 5. 4 minus 5 would be negative 1. 5 minus 5 would be 0. Again, I have a number over 0, so I know my limit is either going to be positive infinity or negative infinity. So as I approach 5 from the negative direction, just a little bit smaller than 5, I'm going to use 4.9. So 4 minus 4.9 over 5 minus 4.9. This is going to give me negative 0.9. Just checking, yep. 5 minus 4.9 would be positive 0.1. So I get a negative over a positive, which is going to be negative infinity then, as x approaches from the left-hand side. As x approaches 5 from the right-hand side. So from the positive direction, just a little bit bigger, I'm going to plug in 5.1. So 4 minus 5.1 over 5 minus 5.1. 4 minus 5.1 would give me, whoa, I put divided by. 4 minus 5.1 would give me negative 1.1. 5 minus 5.1 would give me negative 0.1. I have a negative over a negative. A negative over a negative is a positive, so I'm going to get positive infinity. So my limit as x approaches 5 from the left is negative infinity. My limit as x approaches 5 from the right is positive infinity. Since those are different, the limit as x approaches 5 does not exist. So 13, 14, and 15, the point where if I evaluate directly and I get a number over 0, and since division by 0 is undefined, it tells me that I'm either going to have a limit of positive infinity or negative infinity. So I want to use numbers very, very close to what I have so that I can see what the sign is, so I know if I'm going to have negative infinity or positive infinity.